So here is the example they had given you that. So this is the source program given with the respective opcodes also given right here. What is opcode of for every mnemonic instruction they had given the opcodes. So now let us start the process. So first, as usual, the pass one, which is the address allocation. Okay, address assignment. So here, if you see the example properly, so the starting address they are given is 105D. Okay, 105D would be the 105D would be the starting address. So then again, so that would be the starting address. Then again, it is here you can observe it is a clear X. So can anyone of you, based on if you really understood the previous example, can you guys let me know which format is this? Format 1, 2, or 3, or 4? Clear X.
1.
So it is, so here you can observe, my dear students. So we have the instruction which has clear and X. So clear is the opcode, X is the register. So the instruction working only on the register. It can be one register or two registers, but it is working only on the register. So it is of which addressing mode? Sorry, which format?
2, sir.
1.
It is format 2, students. It is not format 1, it is format 2 because it is working only on the registers. So it is format 2, for which you need to allocate 2 bytes. So if you allocate 2 bytes, it will be, what will be the next address? It is 105D is the first address. I'm just starting address is what? Let me write as 105D. So the next address would be 105D plus 2 is what? D plus 2, 5, F. D plus 2 is F. Again, Ldt length. It is not acting on the registers. It is not acting on the register, so it is acting on some operand. So it can be format 3 or format 4. But I told you the instruction like this, the instruction with where the opcode is preceded with the plus, such kind of instructions are a format 4, rest are format 3. So this Ldt length is format 3, not the format 4. So for which you need to allocate 3 bytes. So what is the next address? 1055F plus 3. So it is F plus 3 is 12. So it will become 601062. If you want, I can also show you that. So you can observe. So it is what in the, you can observe it is 105F plus 3 is what? 1062. Again, TD input. What is TD input? Sorry, what instruction is this? Again, it is a format 3, which is not acting on the registers only. So it is format 3. So for which if you add 3 again, so it will become 1065. Again, JEQW leap. Again, it is a format 3. It will become 1068. Now see, my dear students, this plus LDCH. Students, before I continue, so guys, am I audible? And is it clear till here?
Yes, sir.
Yes, sir.
Now you can observe right here, it is plus LDCH buffer comma X. When you say plus LDCH, so it is a format 4 instructions. Mind about it. It is a format 4 instructions. For format 4 instruction, how much memory space you need to allocate? In the sense, it is 4 byte. So 1068 plus 4, it is 1068 plus 4, it will be a 106C. Okay, 106C. It is 106C. It is plus 4. Again, WD output, it is again format 3. So it 106C plus 3, you get 106F. Again, here you can observe it is TXL T. T is what? Register. T is what? Register. It is as same as clear X. So TXL T, which is acting only on the register. When it is acting only on the register, it is a format 2, for which you need to allocate only 2 bytes. So the next address would be, so F plus 2 is 12, so you will get 1072. Okay, 1072. Again, JLT W loop, again format 3. So you will get 1075. And R sub, my dear students, this is where try to understand the consequence clearly. See, what when I spoke about the formats, like different formats in SIC XC. So I told you that format 1 will be having only opcode. That is true. So here, if you see here, it has only opcode. Here it has only opcode, which is not having operand. But the thing that, so by considering that, you can say that R sub is a kind of format 1 instruction. I repeat, you can say that by looking after the format of the format 1 instruction, you can say R sub is a format 1 which has only opcode, no operand. You can say it is format 1, but I will say this as a format 3. Why I should consider this as a format 3? My dear students, understand this. Why you should consider this as a format 3 means, what is the functionality of R sub? It is return from subroutine. If you ever remembered when we spoke about the theory, the different registers, when we taught the two registers, if you understood, like a PC, which is program counter to hold the address of next instruction to be executed. At the same time, we spoke about one more register, which is linkage register, the L register, which is to hold the return address. So whenever you execute this R sub, for you guys, for us, for looking, yes, it is only the opcode which it doesn't require address for looking, but actually if at all this R sub has to be executed in the sense, it also requires the address. But what address? In the sense, the address of the linkage register. I repeat, you should also have the address of the linkage register, then only this R sub which is returned from the subroutine can be executed. So you need to return back from this subroutine to the main routine. That can be accomplished only when you have the when this will make use of the linkage register. In such consequence, my dear students, so this cannot be a format 1. This need to be a format 3 instructions. I repeat, so by looking to your format, it has only opcode, no operand. By looking, you can say that this is a format 1 and you need to allocate only 1 byte by looking. But when you think of operation, when you think the actual operation of it, you can't say it as a format 1. The reason that in order to execute this, I repeat students, in order to execute this, definitely you must have the linkage register or address of the linkage register, then only you can execute. In such consequence itself, you need to consider this R sub as a format 3 instruction instead of the format 1 instruction. Okay, you need to consider this as a format 3 instruction. So wherein you need to allocate 3 bytes, so you'll get 1078. Now again, here you can see output byte where x of 05. Can anyone of you let me know how much memory space I need to allocate for this output byte x05? How much bytes I need to allocate?
2, sir.
Just to check once, how much memory space need to be allocated?
1 byte.
It is 1 byte or 2 bytes?
2 bytes.
1 byte, sir.
Why 1 byte?
Hexadecimal takes half byte, so each.
So there are 2 hexadecimal numbers, so which requires 1 byte. So for this you will be allocating only 1 byte. So what is that 1 byte? It is so that you will becomes 1079. Again here you have reserve byte 400. I repeat, you have reserve byte 400. How much space need to be allocated right here? It is reserve byte 400. So how much need to be allocated here?
400.
4. It is not, you don't need to have 400 into 3, because my dear students, if it is reserve word, then you supposed to go for 400 into 3. It is not reserve word, it is reserve byte. Same examples we had in the SIC as well in the previous examples. It is not 400 words, it is reserve byte 400. So you need to allocate only 400 bytes. If this could be, if this is reserve word, then you could have, you supposed to allocate 400 into 3, which is 1200, those many bytes. Whereas right now it is only RESB, which is reserve byte. So you need to allocate only 400 bytes. You don't have to multiply by 3 because it is RESB, it is not RESW. So it is 400 bytes. But you can't add this 400 directly to the 1039. Even this story I spoke in the SIC case as well. You can't add this 400 directly to the 1039. What are you supposed to do in the sense? You need to convert that. You need to convert that. So converting from where? In the decimal it is 400. What will be the hexadecimal? It is the 190. So decimal value 400 need to be converted to the hexadecimal value 190. That 190 need to be added to this 1079. So 190 plus 1079 you got as 1209. You are getting as 1209. Again plus. So here you can observe it is length reserved by 2. So how much space need to be allocated? It is only 2 bytes. It is not RESB. It is not RESW. It is only RESB. So you need to allocate only 2 bytes. So next address would be 9 plus 2 is what? B. So you get as 120B. Guys, are you getting this point? Is it clear till now?
Yes, sir. Yes, sir.
So that's how we are done with the memory allocation or address allocation. Now let me take you to the object code generation. Okay, let me take you to the object code generation again as same. So let me make use of this template itself. So we have used this. Let me use that itself. You can observe right here. If you observe here clearly, this is what the format 3 instruction which I have given here. Okay, so I hope thinking that from the previous example you understood. Now if I take you directly with the, instead of writing the formats, so I'll directly take you to the object code. Okay, so this is the, see, you can observe clear X is the format 2 instruction. Clear X is the format 2 instruction. So what is the opcode of clear? You can observe it is B4. The opcode of clear is B4. B is how to write B. It is 1011 is the B. And 4. It is what? 0100 B4. And in case of format 2, if you ever remember, in case of format 2, so the format what it says, opcode is of 8 bits. So 8 bits. Again, register 1 and register 2. What is the register 1 here? It is X. The register number of X is, what is the register number of X? If you see, so register number of X is what? 1. Register number of X is what? 1. So I'll write as 0001. And what about the register number 2? Here the second register is missing. When there is no second register, so we'll directly write as 0. I repeat, so as there is no second register, we'll directly write as 0 because there is no second register. So based on this, what is the object code you're getting? It is B410. That's the object code. I hope you're getting. If not, you can ask me. Then again, next instruction is Ldt length. See, like when you talk about Ldt length, which is again a format 3 instruction. I repeat, it's a format 3 instruction which will be having opcode of 6 bits, right? Which will be having opcode of 6 bits followed by NXBPE. Okay, this is a opcode of 6 bits followed by NXBPE followed by displacement. Okay, that's the format 3. Now LDT, what is the opcode of LDT? It is 74. 74. I'll say 0111 is 7 and 4. I'll say only 01 because I have to fit it with the 6 bits only. I hope you remembered. You need to fit with the 6 bits only. The opcode of LDT followed by the N and I. So it is neither preceded with the @ or nor immediate. So it is both 1 1. Again, it is not using X register. So X is 0. Again, coming to B and the P, I'll leave empty, and E as in format 3, it is E, I'll make it as 0. And next is displacement. I hope you remembered. So we had given the formula here in the previous example itself, how to find out the displacement. So how to find out displacement? We have the formula that operand address minus the PC value. The same formula itself we are going to use it. I repeat, the same formula itself we are going to use, such as, okay. So here, when you say operand address minus PC value, in this example, or sorry, in this instruction, the operand is what? Length. What is the address of the length? You can observe it is 1209. Address of length is what? 1209. Okay, so it is 1209 minus the PC value. For this instruction, what is the PC value? We are at this instruction right now. Okay. We are at this instruction right now. When we are at this instruction, the PC will be holding the next address. What is the next address? It is 1062. The next address is what? 1062. So 1209 minus 1062. When you subtract 1209 minus 1062, what is the value you are going to get? So you are going to get as what? So 1209 minus 1062. So you are getting as 1A7. I hope you can observe, my dear. It is 1A7 you are getting. You are getting as what? 1A7. But let me expand that. 1. How to write 1? It is 0001. How to write A? It is 1010. A is what? 1010. Again, how to write 7? It is 0111. That's what? 1A7. And 1A7, is it greater than our range of your PC mode? I hope you remember PC. I told you that maximum and minimum limit. So you can observe. So PC mode, the maximum limit is 2047. Is it greater than 2047? This 1A7? No, right? Because see, when you subtracted this, you got us what? 1A and 7. This 1A7 is not greater than 2047. So to find out this displacement, which register we made use of PC or base. So we made use of PC. So P is 1 and B is 0. Based on this, generate the object code. It is 7. Okay, 7 followed by again 3 1 1 1 1. So it is 7. Again 0010. It is 2 followed by 1 A7. 1 A7. That's the object code for U. Right? I hope you guys are understanding. That's the object code of the Ldt length, which is format 3. Students, are you understanding?
Yes, sir.
Yes, sir. I take up the next example. I'm just going a little faster when I compare to the previous example because I hope you understood the previous example in detail. Okay, so now if you observe TD input, what is the opcode of TD? So TD, it is given that what is the opcode of TD? Yeah, E0, E0. So how to write E? It is 111, 0 is E, and 0 is what? 00, not 4 zeros, because we need to fit it in the 6 bits. Again, as usual, it is neither indirect nor immediate. So it is 1 and the 1. It is not using X register as well. So B and the P, let me leave space, and E is 0. Now find out the displacement. How to find out the displacement? As usual, the operand address minus the PC value. Here, what is the operand? It is the output is the operand. What is the address of the output? Here you can observe it is 1078. 1078 is the operand. Now, so here itself, let me write. I hope whatever I am writing, it is visible to you all clearly.
Yes, sir.
So I'll write the operand address is what? 1078 minus PC value. When I am working with this instruction, the PC value is what? Next address, it is 1065. So it is 1065. When you subtract this, which is 1078 minus 1065, 1078 minus 1065, what I'm getting? It is I'm getting as 13. I'm getting as 13. Let me write as 013. Right, I'm getting as 13. So as I'm getting as 13, which is not greater than 2048. Okay, which is not greater than 2047. So for finding out this displacement, I'm using which register? I'm using the PC itself. So P as 1, B as 0. And how to write this 013? It is 0 and 0, 1 and 3, 11, So based on this, generate the object code again. Now it is E by 0011. The 0011 is what? It is 3. 0011 is what? 3. Followed by 0010, it is 2. Followed by 0 and 1 and 3. I hope you guys are getting my point. If not, you guys can ask me. Then again, next instruction is what? If you guys are not understanding, please ask me. Next instruction is what? E W loop. JEQ W loop. What is the opcode of JEQ? You can see it is 30. So it is 0011 is 3 and 0 is 30. Followed by it is neither immediate nor indirect. It is not using X as well, and it is format 3. Now find out the displacement. How to find displacement? The operand address. What is the operand here? It is W loop. I repeat, the operand is what? W loop. So what is the address of that W loop? It is 1062. Make a point of this, my dear students, which is very, very important right now, which I am talking right now, which is 1062 minus the PC value. What is the PC value? Where you are working? We are working in this instruction right now. What is the next address? It is 1068. So 1062 minus 1068. I repeat, 1062 minus 1068. What do you get? When you subtract 1062 minus 1068, so definitely you'll get one or the other negative number. So 1062 minus 1068. So you're getting what? Understand, my dear students? When you subtract this, so normal subtraction, when you make it as 1062 minus 1068, you would get as minus 6. But if you ever remember the address, the data representations from our both SIC or SIC XC, if you remembered how to represent the negative numbers, my dear students?
2's complement.
Exactly. So negative numbers are represented as 2's complement. Now we are doing that itself. When you subtracted this 10, yeah, when you subtracted 1062 minus 1068, we got as minus 6. But when you represent, you can't represent minus 6. So that minus 6 has to be converted to the 2's complement. But how to take 2's complement? If you ask me how to take 2's complement, just for your understanding, I'll write here. Okay, I'll write here for your understanding. I'm writing here. If you get any doubts, you can ask me. So here, students, so you are getting as one when you subtract 1062 minus 1068, you are getting as what? Minus 6. You are getting as what? Minus 6. But you can't take up this minus 6. Basically, what is 6? 6 what? 0 1 0 0 1 1 0 is 6. But how to take it as a, how to represent in the negative format? So for this, I'll just take it as 006. 1068 minus 1062 minus 1068 006. How to represent that? So it is 000 followed by 000. So that's how I'll be representing as 006. But how to take it as negative 2's complement? First I have to make it as 1's complement. When I make it as 1's complement, I'll get 1111 followed by 1001. That's the 1's complement. When I make it as 2's complement, if you ever remembered how to make it as 2's complement, this is what? Plus 1. Do you know, guys, this story, you know that, you know, right?
Yes, sir.
So when you do this, when you do this, if you see here 1 plus 1, what do you get? It is here 1 plus 1 you get as what? 0. It is 1 0. So what you are going to get, you know what? So you'll get 1 1 1 1 followed by 1 1 1 followed by 1 0 1 0 1 0, because 1 plus 1 is what? 0 and followed by carry 1. So 1. So this is how you are going to get. Even you in your calculator also, what did you get? You can see F F A. Is this not F and the A? So what you are going to get here? This is what? This is the displacement. This is the displacement you got, which is F A. For which again you made use of PC itself. You did not make use of base relative. So here E, it is still 0. It is format 3. Now what is the object code you got? It is 3 again 0011 3 again 0020, sorry 0010. It is 2 followed by F A. Students, before I continue, did you understand how we got FFA?
Yes, sir.
Now next it is LDCH buffer comma X. I'll say LDCH buffer comma X. It is a format 4 instruction. I repeat, it's a format 4 instruction. As usual, what is the object code, opcode of LDCH? It is what? 50. You can observe LDCH is 50. So I'll say 0101 is the 5 and 0 50, right? And I'll be neglecting the last 2 bits as usual. Again, so it is neither indirect nor immediate. So it is, because it is not having either at the rate or a hash. So 1 and 1. And is it making use of X register? Definitely yes. It is using the X register. So X is 1. Again, B and the P. If you ever remembered from our previous slides. So if you ever remembered, in case of this base relative and program relative will never be applicable for format 4. It is only applicable for format 3 only. So here B and the P, I can directly make it as 0 0. Whereas what about E? It is 1 for format 4. You are getting, guys? Students?
Yes, sir.
Yes, sir.
Now in our format, in our format we have the address of 20 bits. We have address of 20 bits. What address? Operand address. What is operand here? It is a buffer. Buffer is the operand. I repeat, buffer is the operand. What is the address of buffer? You can see 1079. 1079 is the address. Let me write as 1079. It is 001 10, right? Yeah, 0 7 and 9. 9 is what? 1001. You can observe, my dear students, I am getting as 1079. But the thing that even after I had written as 1079, totally how many bits are there here? It is of only 16 bits. I repeat, you have only of 16 bits. Even after I have written as 1079, you got as only 16 bits. But as of your field, it is of 20 bits. So at the beginning, I will be adding 4 more zeros. So you are getting as, let me push this separately. Whatever I am doing on the slides, I hope it is visible to you all. If not, please ask me. I'm just making something like, so that you can understand better. Students, it's visible, right? Whatever I'm doing here.
Yes, sir.
So we made it as it is the actual operand here is buffer. address of that buffer is 1079. But even after you write as 1078, it's of only 16 bits. But field is of 20 bits. So in order to make it as 20 bits, we are adding 4 more zeros. Okay, we are adding 4 more zeros to make it as 20 bits. Now what is the object code? You see, this is 5, 0011 is 3. Again, 000. Again, this is what you can observe. It is 1001. 1001 is what? 9 followed by 01079. You can observe totally how many digits are there. 8 digits should be there because 4 bytes, right? For format 4. Students, are you understanding?
Yes, sir.
So format 4 bytes, right? So that's how. So that's how we'll be generating the object code for the format 4. Okay, so we are done with the LDCH buffer comma x. Then again WT output. Again, it is a format 3. I hope you know that format 3. What is our opcode of WD? WD is DC. How to write D? It is 10. No, 1101 is D. Followed by C. How to write C? It is 1100 is C. So I'll write only 11. Again, it is same way. It is neither immediate nor indirect. It's not using X also. Again, coming to the E, it is 0. How to find out displacement? As it is format 3. So find out by using this operand address minus PC value. But what is the operand here? It is output. What is output? It is 1078 is the address of output. So this would be 1078 minus what is the PC value for this instruction? What is the PC value? It is 106F. It is 106F. When you subtract 1078 minus 106F, 1078 minus 106F, you are getting as what? 9. So you are getting 009, I'll say. So again, as usual, it is in the range of 2048, 2047. So for which you'll be setting B as 0, P as 1. So what is this displacement or address? It is 0, 0 and 9. So what is the object code you got? Finally, it is what? You can see D and 4 ones. It is F and 2009. That's the object code for you. Next, students, are you understanding? Next, I'll go with one more. The next instruction. If you see the next instruction, so here it is TIXRT, which is format 3 instruction, my dear students. This is format 2. Format 2. TIXRT is a format 2, which has what is the opcode of TIXR? You can see it is B8. So it is B and 8. Again, you have a T, register T. The register number of T is 5. So 0101. And there is no second register. So as usual, it is zeros. So what do you get? It is B850. That's the object code for TXRT. Next, you have JLT W loop. Again, it is a format 3 instruction. It's a format 3 instruction. Let me write here. Again, as usual, what is the opcode of JLT? JLT is 38. So write as 3 and 8. 8 is only 100 is 8, but it is only 10 because 6 bits. Again, so neither indirect nor immediate, even it's not indexed as well. Again, coming to the E, it is 0. Now find out the displacement. What is the operand here? It is W loop. I repeat, W loop is the operand. So again, same way like this, you need to find out. So same way you will get. Let me copy paste here itself. So what is the operand address of W loop? It is the 1062 minus what is the PC value? As you are here, what is the PC value? It is 1075. Okay, it is 1075. When you subtract 1062 minus 1075, so you will get as 1062 minus 1075. You will get as FED. You are getting as what? FED. Same way. So it is as same as when you do 1075 minus 1062, you get as 13. 013. When you convert this 013 to the 2's complement, okay, if you take the 2's complement process the same way, however I shown here, like that, if you take the 2's complement process, students, did you understand this? How to take the 2's complement? You want me to show this for this also again? Take the takes 1's complement, then add 1. When you do that, which is 1062 minus 1075, you get as FED. I repeat, FED. FED is nothing else. F, it is F, E, and D. Is what double one is the D. So again, as usual, for finding out this, so see, even you are getting minus 13. It is not less than. See, we are getting as minus 13. It is not less than 2018. Sorry, 2048. Right? It is not less than 2048. So it is still a PC. P is 1, B is 0. What is the object code you got? It is 3 and 1011. It is B, 2 and FED. That's the object code for JLT loop. Again, next instruction is R sub. Again, as usual, what is the object code for R sub? It is what 4C. It is what 4 and C is what 11. Again, if you ask me what is this N and I, it is 1 and 1. X is 0. B and the P is 0. And the format is 3 is also, it is 0. And what is the address? Here you can see there is no operand, so address would be zeros. As there is no operand, so operand address is zeros. And for finding out the operand address, we neither made use of base or neither made use of PC. So it is 0. Now what is the object code you are getting? It is 4F. It is 1111F 0000. That's the object code for R sub. Finally, byte, output byte 05. And it is a hexadecimal 05. As it's already in the hexadecimal, so 05 itself would be the object code. And for there is no object code for the reserve byte instructions. So that's what the object code for these instructions. Did you understand, students?
Yes, sir.
Now finally let us generate the object program. Let us generate the object program. So as usual, we'll be having H followed by the name of the program. It is WRREC. REC is the name of the program. What is the starting address? You can see it is 10001005D. And what is the length? If you ask me the length, subtract last address minus first address. What is the last address here in the program? It is 120B, okay, minus 105D. So the length you are getting as 1AE. I repeat, the length of the program you are getting as 1AE, but here we will be writing as 0001AE. That's the header record for you. Next, followed by text record. T followed by the starting address where you are where you have the object code. It is 00105D. Again, length I'll leave it as space. Then followed by I'll start filling this, which is, you see, B410 followed by 7721 A7 followed by I have E32013 followed by 53901079 followed by DF2009 that is followed by B850 that is followed by 3B FED, which is followed by. I hope you guys are understanding. This is a continuation of the same text record.
So yes. You left one in the middle, so.
For which I did?
After E32013, it is 332FFA.
Yeah. This is what 332FFA. That's good. So next, FFA. Next, so here let me break the chain like this. So again, after 3B to FED, it is 4F, 4 zeros, again followed by 05. That's the text record. Now again, if you want, you can count off. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is what? 8 plus 3, 11, 11 plus 3, 11 plus not 3, it is 11 plus 4, it is 15, 15 plus 3, 18, 18 plus 2 is 20, 20 plus 3, 23, 26 and 27. When I convert 27 to the hexadecimal, I'm getting as what? It is 1B. So the length of the this text record is 1B. And finally, I'll be writing the end record. E followed by the starting address. What is the starting address here? It is 105D. So it is 00105D. That's the object program for you for the given source program. Students, are you understanding?